All right, let's look at the question on the screen. So let's say, yes, we're going to be doing special angles today. Yes, we need to answer this question, guys. Now, remember, what we've got on the screen over here, this is your x coordinate and your y coordinate. So if I draw a line from the origin to the point, that is going to be my r, my radius, or my hypotenuse. And then this part over here, that is going to be my y, which is going to be 1 in this case. And this is going to be my x, which is 3. And my angle theta will be the part that this part over here, the 0 degrees, 90 degrees, all this lovely stuff over here makes with the x-axis. So this angle over here will be the theta I'm looking for. Now, if I have theta, guys, if I know I'm looking for theta, this side is going to be called a particular side. And the side all the way over there is going to be called something else. I know you guys know what it's called. So go ahead and let me know what this side over here, what the x side is called and what the y side is called. Hello, Palisa. Always awesome to have you with us. All right, and I would like somebody to find me r, the radius, or in this case, the radius can also be known as the hypotenuse. So remember, this creates like a right-angled triangle type of effect. All right, so we can take it from there. Funzo, what's up, my sweetie?
Hi, ma'am.
Hello, my sweetie.
I was asking if I could find R.
Yes, absolutely. How are we going to find R?
So I said I use Pythagoras.
Absolutely, yes, we should.
And I say I say x squared plus y squared is equal to r squared.
Beautiful. And your
then
reason?
I said Pythagoras, I think.
Yes, Pythag. You must always give your reason. You must give your reason. Pythag. Okay, what was your next line?
Then I said 3 squared plus 1 squared is equal to r squared.
Beautiful. Okay, then we got?
Then I said 9 plus 1 is equal to r squared. Then I said 10 is equal to r squared. Then I square rooted them.
Good, it's equal to r squared. Therefore, r is going to equal to the square root of 10, right?
10.
That's it. Okay,
Yes.
good. So this is the square root of 10. Beautiful. You found r for us. Do you know how we could possibly find theta? Any idea?
I think we're going to say.
Okay, remember, what do I have? What do I have? And what do I want?
We have our opposite and our adjacent.
That's it. We have the opposite and the adjacent, and we want our angle. And as soon as we look for our angle, what are we going to click? What are we going to click on our calculator? Shift. Good. We're going to click shift. Right. And then you need to think between saw and car and tower. Which one are we going to use?
Saw.
Well, yes, we could use saw. Considering that you told me that we have opposite and adjacent, which one uses O and A? Tower. Good. We can use tower. Okay. I recommend we use tower, Funzo, because that's the information they gave us. Just in case we didn't calculate our R correctly, then we don't want to use the hypotenuse in case we didn't calculate it correct. Okay. So we're going to go tan of theta is equal to, finish my sentence for me.
Opposite over adjacent.
Beautiful. And that is equal to, opposite over adjacent is?
1/3.
Excellent, 1/3. And then you said if I want the angle, I need to click?
Shift.
Good. So go to your calculator and click arctan of 1/3 for me and give me an answer. Therefore, theta is equal to?
18,43.
Good. 18,43 what? Angles are measured in degrees. Yeah, that's it. Excellent. Degrees. All right, let's finish it off. Let's take it home. Funzo, I want you to give me sine of theta in terms of the sides that I have here. What is sine of theta going to be equal to? Remember,
it's going to be opposite over hypotenuse.
Good. So what is my opposite side equal to? It's going to be
1 over the square root of 10.
That's it. Good. We're going to have 1 over the square root of 10. Well done. This is everything. You just kind of summarized everything we did on Monday. You remember we did all of this?
Yes.
Excellent. Excellent. I'm so proud of you. You remembered all of it. That's amazing. Well done. Sheesh. Excellent stuff. Thank you, Funzo. That was awesome. For those of you who didn't join us on Monday, because I'm seeing in the chat, we're doing special angles today. And the angles on the Cartesian plane is what we did last time. Now, I'm just going to show us the 2 mnemonic devices that we should actually have learned. So if we've got a point over here, the point, it doesn't matter what the point is. The point will have an X coordinate and a Y coordinate. We're going to do this. We're going to go. Okay. Whatever our X coordinate is, the length of that is our X side over here. And the coordinate, whatever our Y coordinate is, that will be the length of the Y side over here. And our angle theta will be whatever this angle over here is, the one between the x-axis and however far our r is, our r or our hypotenuse. Now, we know that if our angle is down here, this side far away from it is our opposite side. This side right next to it is our adjacent side. Now, we know that we can talk about SOHCAHTOA in triangles. But when we look at things on the Cartesian plane, we have to consider them in terms of x, y, and r. So our SOH or our sine is going to be sine is equal to, my opposite is y over my hypotenuse, which is r. My cos is going to be x over my adjacent over my hypotenuse, which is r. And my tan is going to be my opposite, which is y, over my adjacent, which is x. So that's how we can think of it on the Cartesian plane. And Ona, if you were not with us on, excuse me, on Monday, this is going to seem a little bit confusing. So we're going to have to rewatch Monday's lesson to understand what's happening over here. Now, I heard Teacher Lee, the matric teacher, actually say the easier way to remember this mnemonic over here is, she says, shade your rear, because x-rays, x, that's x, and then the rays belongs to r, because x-rays tan your exterior. Okay, so basically what she's saying is shade your, like cover up your butt, like your buttocks, because the sun, x-rays from the sun, actually, they're going to tan, they're going to give your booty a nice tan. So the way we can remember SOHCAHTOA in terms of the Cartesian plane is if we go shade your rear because x-rays tan your exterior. I know. When I heard it, even I was like, man, what? Say that again? I know. Oh, I'm going to have to go get a glass of water in a bit. Yeah. So shade your rear because x-rays tan your exterior. And now you'll never forget it. Okay. You'll never forget it because it's pretty cool. But if you remember that we have SOHCAHTOA, you can always just draw your triangle with x, y, and r, and then you can use opposite to get what sine is and adjacent to get what x is, all of those kinds of things. But I found it just a little bit funny. It was just a little funny. You can remember that if you'd like, take a screenshot, because we are actually working on special angles today. As the lovely Puseleta has asked for, we're going to be working on special angles. All right. Okay, that was the homework that we had to do. All right, special angles. All right, remember we said that for special angles, and I lied to you guys, I'm going to add one more 0 over here, 0 degrees, because 0 degrees is also very important. All right, we said that when we're looking at special angles, we can learn 2 different types of triangles. We can learn the 60-30, and we can learn the 45. These are the only 2 triangles that we really need. The reason why the 60-30 is for both is because of the interior angles of a triangle. If this part is 90 degrees and I draw a 60-degree angle over here, this angle over here is automatically going to be 30 degrees. So we can learn the 60-30 triangle, the 60-degree triangle and the 30-degree triangle together at the same time. And then the 45-degree triangle is pretty easy because I know that the 2 sides, the 2 short sides are equal in length. Okay, so remember how we said we were going to learn the numbers that go along with it. On the 60-30 triangle, we always say 1, 2, root 3. 1, 2, root 3. Okay, it's easier to remember when we can see the numbers. Okay, there's a 1 at the bottom, a 2 at the hypotenuse, root 3 this way. Okay, and then with the 45-degree angle, it's going to be 1, 1 for the shorter sides, 1, 1, and for the long side, root 2. Now, this is something that you're going to have to commit to memory because you are not given, it's not given to you in an exam or in a test. So what I used to do when I used to get an exam paper or a test paper in school, as soon as they like, write your name, you know, that top part where they say name, I would go Coco, and then I'd go 1, 2, 3, 60. And then I go 1, 1, root 2, 45. And then I'm like, whew, okay, now I can look at the rest of my questions. And then I start looking at the questions to make sure that anything that comes up after this, I've kind of already got my triangles there, and I don't have to like continually have to remember the triangle again and again and again, because special angles are going to be used constantly. Now, today, I'm going to let you guys cheat because I'm going to put the triangles there and you guys can give me the answers based off of the triangles. So I want volunteers. Let's start with the sine of 45. If I want to figure out the sine of 45, I'm going to use the 45 triangle. Okay, who can tell me, according to the triangle, what is the sine of 45 degrees? Have a look at the triangle. Now remember, if this is my angle over here, this side over here is going to be my adjacent side. And this side over here, my opposite side. That's it, Puselito. And this is my hypotenuse. Good. So if I have to look at sine of 45 degrees, I'm going to get 1 over the square root of 2. Now, I know that this is what it says over here. And I have a feeling in grade 10, this is something I am going to have to ask about if in grade 10 they'll allow you to write 1 over root 2. Because if you actually type sine 45 into your calculator will give you this answer. It go root 2 over 2. That's what your calculator is going to do. Now, at the moment, you need to learn both of these. Okay, 1 over root 2 and root 2 over 2. But neither of them is wrong. They're both correct. Okay, they are both correct. You don't have to worry about using one over the other, but both of them make up the same thing, basically. Okay, all right. What about cos of 30? Anybody got cos of 30 degrees for me? Yo, Jonathan, that was pretty fast. Good, yes. I'm going to go to my 60-30 and I'm going to have a look. Oh, this is my adjacent to my 30 degrees. This is my hypotenuse. Therefore, cos of 30 is going to be root 3 over 2. Okay, that's it, A over H, but in my 60-30 triangle. Okay, we're going to do it in my 60-30 triangle. And then remember, guys, when I get to the 60 degrees part of it, the sides are going to start changing. Okay, so I need to make sure I'm remembering that. All right, now I want the sine of 30 degrees plus the cos of 35 degrees. What is that going to give me? First, let's figure out what's the sine of 30 degrees. Good. All right. So if this is my 30 degrees over here, sine is going to be opposite over hypotenuse, which is 1 over 2. 1 over 2 plus the cos of 45 is? Anybody got any ideas? Have a look at your 45-degree triangle. The cos of 45 degrees. Cos is adjacent over hypotenuse, but what is it? That's at Letabo. It's 1 over the square root of 2. Hi, Olwetu. Oh, I'm seeing Olwetu's feet at the moment, so I'm not 100% sure what's going on. Hi, Olwetu.
Hello.
How are we doing? I'm good, thank you. How are you?
I'm fine. No, I was just testing the feature. So sorry to disturb the
no worries.
lesson.
Okay, no worries. Okay, all right. Now, in this case, when we have something like 1 over 2 plus 1 over root 2, your teachers are going to be like, no, that answer is not good enough for me. Give it to me as one answer. And if I'm adding 2 fractions, guys, I'm going to have to go and find an LCD. Okay, anybody got any idea what is my LCD going to have to be here? Who's got an idea? What is my LCD? Yes, Mkhengi, you've got the right idea. It can't just be 2, guys. Remember, the square root of 2 doesn't go into 2. So the only way we're going to be able to find an LCD here is if we multiply the 2 of them together. Together. So I'm going to have something over 2 times the square root of 2. So we're going to multiply them together to get our LCD. Then I know that this part of my LCD over here is missing root 2. So I'm going to multiply the top with root 2. 1 times root 2 is just the square root of 2. And over here, this part of my LCD, or the part of my denominator, is missing 2. 1 times 2 times 2. That's just going to give me 2. Okay, it looks ugly. It's very ugly, but at least it's one thing. Okay, and you will get the marks that you need in this case. All right, let's look at number 4. Okay, let's look at number 4. They want the sine of theta plus cos squared 45. Okay, so what is the sine of theta, guys? Let me know. What is the sine of theta? Of 30, not theta. Sine of 30 degrees? I think maybe that's why Puseletso keeps going adjacent over hypotenuse, because I think I'm saying 30, but I'm actually saying theta. I'm sorry. I mean, what is the sine of 30? Yes, 1 over 2. Good. 1 over 2. Plus, now remember, guys, if something says to me cos squared of 45, what I'm actually going to do is I'm going to go look for the cos of 45, and then I'm going to square it. I'm going to take whatever answer I get, and we're going to square the whole thing. All right. So I want you guys to tell me, what is the square or the cos of 45 degrees? Yo, I even forgot. Girl, that's not English. I'm sorry. Okay. The Lacero Kakatu. Ooh, girl. Okay. The square root. Now I'm saying the square root. Palisa, you see what you're doing to my English. What is the cos of 45? The cos of 45 is 1 over. Oh, and now. Palisa, I blame you. I blame you for where I'm at the moment. 1 over root 2. But now what we have to do, because it was cos squared 45, we have to take 1 over root 2 and square the whole thing. All right. And what that's going to give me is 1 over 2 plus, guys, what is 1 over square root 2 all squared? How much is that going to give me? I can tell you the top is just going to be 1 squared. So I'm going to get 1. What about the bottom? What is root 2 squared? It's 1 over 2. You're correct, Jonathan. Well done. Right. And now we just have to add them together. Puseletso just said, ma'am, how do we do cos square? Okay. Puseletso, you're going to ignore the square for a little bit, and you're just going to do cos of 45. And whatever answer you get for cos of 45, square that answer. Okay. Find the square of that answer. All right. Final answer, guys. A half plus a half. Half plus a half, everybody. If y'all get this one wrong, I swear. Okay, good. It's 1. It's 1. Yes, a half plus a half is 1. Good. Okay, I'm glad we're all still awake. All right, I want you guys to try the cos of 30 plus the tan of 60 and tell me what you get in the chat. And then if you're feeling brave, do number 6, number 7, and number 8. Okay, I'm going to give you guys a few minutes to go through that. But before we even continue, because I just realized that I forgot to ask if we have anybody new today. I skipped over that. I was just like, flying. Is there anybody, if there's anybody who's joining us for the first time, please, you can type in the chat, hi, I'm new, or you can raise your hand so we can give you a nice big fat Watobe welcome. My mind just was like, hey, maths, we must get there. If you're joining us for the first time, please let us know. Moteo, really? Olwetu and Zbonga, yes, you see now how that feature is working for you. Yes, because you were testing it earlier and now it's working for you. Very well. Welcome. I'm wondering if it's Olwetu and Zbonga or if it's just Olwetu and then like the name just happens to be like the name on it is just kind of together. Don't even. Ona is new, hence the confusion. Absolutely. Okay, Ona, the problem is we are on lesson 6 of 6. So you are joining us in the last lesson. And that's why we're confused about everything. Okay, so you've missed 5 whole lessons. And I 100% understand the confusion. So Ona, I'm just going to ask you, quickly, can you just let us know what topic you're doing at your school at the moment? Have you done trigonometry yet? Kunzo, I'm seeing that answer. I'm kind of sort of agreeing. Plus 10 of 60 is root 3 over 1. Good. But then because you're adding 2 fractions, you still need to give me an LCD and make the answer 1. Okay. So your answer is 100% correct. I just need you to add them together and give me an answer because they're both fractions. Tsepo hasn't done trig yet. Okay, but Tsepo, are you joining us for the first time today? Oh, Teacher Niles, don't let Tsepo fool you. Tsepo's been here. Tsepo helped us clean the carpet last weekend. Remember, he was there scrubbing. He mustn't lie to you.
And he's like, my name is Tokyo.
Sure. Cheese. Yo, okay, your school is taking their time, and I'm not 100% sure. Sure, Jonathan, you're killing these 100%. That's good. Yes, I agree with you on that. 1 over, are you sure it's not 1 over 2? Have a look again for me. I have a feeling it might be 1 over 2. Or maybe just 2. Oh no, they're both tan. No, you're, okay. So the answer must be maybe 1. I think it should be 1. Have a look at number 6 again. Okay, I'm gonna write down the answer for number 5 quickly. Okay, number 5 is root 3 over 2 plus root 3 over 1. Guys, don't even buy it. Not even a little bit. He's been a part of the family, guys. He made us dinner last night. He mustn't lie to you. Okay, this is going to be on the top. I'm going to have root 3 plus 2 times root 3, that gives me 3 of them. So I'm going to have 3 root 3s over 2. That's the final answer that I'm going to get. And then for this one, oh, I'm sorry, Tebo. Yeah, I could tell that you're a little sly. Okay, sorry, Tebo. It's just such a gender neutral name. And now I'm not sure if it's a he, she, they, them. I don't know. Okay, I did not mean to offend. I'm sorry, my sweetie. All right, tan of 30 is opposite over adjacent. That's 1 over the root of 3 divided by tan of 60, which is root 3 over 1. So together, this should give me 1 over 2 root 3. No, 1 over 3. Yes, Jonathan, I'm the one who's 100% not there. So if I have to tip and times, I'm going to get 1 over root 3 times 1 over root 3. And then 1 times 1 is 1, and root 3 times root 3 is indeed 3. Well done. Yes, I'm the one who wasn't looking at it 100%. Yes, Alicia, correct. Yes, honor at your school. All right, number 7. I saw somebody put an answer for number 7 in the chat. Starting with reciprocals. Oh, we've already done reciprocals. Honor is referring to the cousins. Just give me a thumbs up if you guys remember the cousins. Anybody remember the cousins, the reciprocals? Buseletso remembers the cousins. Yeah. We've done the cousins. We have. Oh, you guys started the cousins today, but Moteo, you already know who they are. That's the one. Shoshatao, that one. Remember? We learned about Shoshatao. That's the one. The sec, cosec, and the cosec, sec, and cot. I know, but it's only by a few lessons. Okay. That's it, Puseletso. That's the one. So we've already done that. And I'll tell you now, Ona, it's quite easy. You catch on very quickly to the answers there. All right. On math 24. Yes. I know, it would be so weird, but it would make sense to you. Unati, it doesn't have to make sense to anyone else. It must just make sense to you. Okay. All right. Sine of 45 degrees, guys, is 1 over root 2 all squared plus cos squared 45 is 1 over root 2 all squared. And that's going to give us 1 over 2 plus 1 over 2, which again is equal to 1. So I hope you guys got that same answer that I got there. Mawande says, ma'am, we are starting lessons on Thursdays now for Tuesdays, or no. Unfortunately, Mawande, we're still going to be continuing on Mondays and Wednesdays. Okay. Hi, Unami.
Hi, ma'am. So, ma'am, I've been having a problem, ma'am, with
Yes.
squaring 10 and sin and cos, ma'am. How do I do that?
Okay, so Unami, what you need to do is, don't worry about the square. Find me, what is the sine of 45? Go have a look at our triangles. Have a look at the 45 triangle. If this is my 45 degrees, my sine is, oh, let's use this one. Sine is opposite over hypotenuse. So I'm going to write 1 over root 2. You agree with me?
Oh,
Sine
yes,
of 45.
ma'am, I agree.
1 over root 2. And then if it says sine squared 45, we're just going to take the answer we got for sine 45 and we're going to square it. That's all we're going to do.
Oh, okay. Thank you, ma'am.
Okay, easy peasy. Yeah. Okay, excellent. I hope those of you who are a little confused got the idea of what's happening. All right, let's look at cos of 30. Okay, cos of 30 divided by tan of 30. Cos of 30 is root 3 over 2 divided by tan of 30, which is 1 over root 3. And then Letu says root 3 over 6. And I'm not 100% sure if I'm agreeing with that, but let's see. All right. Am I wrong here? It's root 3, right? It is root 3.
Yeah,
Teacher
you
notes.
10 times. Yeah, it's right.
Right? Remember, we're looking at the 60-30 triangle. So tan
Yeah,
of
the
30.
final answer will be root 3 over 6 because you tip in times.
Yes. Okay. So if we tip in times, I'm going to get root 3 over 2 times root 3 over 1. But root 3 times root 3 should just give us 3. And then at the bottom, 2 times 1 should give us 2. So we should just get 3 over 2 as an answer. Puseletso? On point. Okay. It's the fractions. The fractions, ma'am. The fractions don't fraction. We don't like them all that much. Palisa, that's so cheesy. I love it. It's going on my wall in my classroom. That's it. Palisa's like, how did I know I wanted to be a math teacher? I saw a sign. You should have started with cause I saw a sign. Love it. The cheesier the maths jokes, guys, drop them in the chat. Yes. Yes, you can. Pusiletso says, ma'am, is it fine if I do root 3 over 2 and 1 over root 3? And then I go straight to the answer. Yes, you can, because you can do like, what is it called? A cross multiplication. Especially if there's a divide, you can cross multiply. Yes. So if you want to do that, go ahead. Okay, you can do that. All right. Okay, just give me 1 second. I need to answer one thing. All right, there we go. Okay, so I just need from you guys a number from 1 to 10. How do we feel about special angles? Now, remember, guys, special angles are about remembering the ratios. It has nothing to do with anything else. You're only ever going to get 30, 60, 45, or maybe the last few that we're going to learn very quickly. These, however, do not come on triangles, so you're going to have to learn them. Okay. We are going to have to learn the ones that come up now. All right. Tikoko, oh, Rainbow Kumo's here. Hi, Rainbow Kumo. There's Rainbow Kumo with the Rand water. Yeah. Okay, thanks, Amy. I see a 10, Puseleta says 7. All right, there are a couple more that we need to learn about, guys. And these, we can't put them on a triangle because of the nature of how they are. So this is going to be the cos of 0 degrees, the sine of 0 degrees, and the tan of 0 degrees. Now, the reason I can't put these on a triangle is because if I had to draw a triangle with 0 degrees, those are just 2 lines on top of each other. So I can't draw a triangle made of 0 degrees, so I can't use a triangle. I'm going to have to remember these off by heart. Okay, but they're nice and easy. Okay, cos of 0 is 1, cos sine of 0 is 0, and tan of 0 is 0. Okay, these are the first that we have to learn. Okay, cos of 90 degrees, tan. Oh, I'm starting with tan instead of sine. I actually should have done it. Don't you think, Teacher Nels, I should have done sine, cos, and then tan because we learn it so katoa?
Yeah.
Now the OCD in me is kicking in. Yeah, okay. Sine of 0, cos of 0. Sine of 0 is 0, cos of 0 is 1, and tan of 0 is 0. Now, let's start again with sine. Sine of 90 degrees, cos of 90 degrees, and tan of 90 degrees. Okay. I'm going to move over a little bit. All right, sine of 90 degrees is 1. Cos of 90 degrees is 0. and tan of 90 degrees is undefined. Okay, we can't find an answer because somewhere in the answer for this, we have to divide by 0, which is an impossibility. So we're not going to go there. Okay, and the reason I can't draw the sine of 90 degrees as a triangle is because I would have 2 straight lines sitting one on top of the other, going in this direction, which is pointless. Okay, we can't draw such a triangle. It doesn't exist. Okay, then the last 3, sine of 180. I'm just drawing zeros, me. Okay, cos of 180 degrees and tan of 180 degrees. Okay, we need to remember these. Sine of 180 degrees is also 0. Cos of 180 degrees is -1. And tan of 180 degrees is 0. Okay, so these we must learn. Okay, the nice thing about them is they consist of only zeros and ones, and the nice one that is always undefined you will never forget, but special angles are meant to be remembered. Okay, I will let you know that in grade 10 they let you use a calculator, so if you forget one, maybe you can, but I can guarantee you your maths moves faster, much faster when you know your sine gerines and your cos gerines and your tangerines. Okay, Unati, when you know your sine gerines and your cos gerines and your tangerines, it makes it a lot easier. So I want you guys to take a screenshot of this on the side and then remember your 60-30 triangle and your 45 triangle. Seppo's like, am I in grade 10 already? Yes, dude, and we're getting there, All right, guys, we're gonna learn one more thing today, okay? But we're not gonna go into too much detail because we're going to be doing that in the revision course when we're looking at word problems. But the last part of trigonometry that we learn about, yes, we've made it to the end. We have made it to the end. We're going to be learning about angles of elevation and depression. I am now elevated because I cannot be sad after I just saw Palisa's cute dog. Oh my goodness, Palisa, you are a distraction. We are busy with maths. You okay? Yes, Kialebocha and Palisa, you're the worst. I can't believe you. I now have to visit your house and kidnap your dog. I mean, what can we do? I know. Alicia, I wish you weren't crying about the depression part. Yeah. I wish you weren't crying about the depression part, but yes, that's what they're called. All right. Lufuno says, ma'am, can you please go back to this part? Amelia was in the bathroom. All right, Amelia, we just learned about these other special angles that we need to know. Okay. Ndubi says, like, this angle is depression. Motel, guys, it's just called an angle of depression. We're not actually depressed. We're just learning about an angle of depression. And Dia was smiling. Okay, all right. I hope you took a screenshot, Lufuno. It's quite needed. All right, you can bring back the calculators, guys. I'm not that mean old person who's not going to allow us to use calculators. All right, so a lot of the time, it's okay, Mlando, it's okay. Maths is not depressed. Guys, it's the same thing. It's exactly the same thing we've been doing. All right, so the angle of elevation, guys, literally means we're going to be looking at a scenario much like our dude Pythagoras was when he discovered the Pythagorean, or when his people discovered the Pythagorean theorem, and much like Hipparchus did when he came up with sine, cos, and tan. Okay. Now, let's say, for instance, here you are over here, okay? Tiny little duty here, work of art. Let me give him some hair. There. Let me give my lovely lady who, there we go. Ooh, I'm an artist of note. I must remember these drawings. I must remember these drawings. All right, so let's say, for instance, you are standing over here, right? And on this side over here, there's a tall building. Okay. Okay, there's a tall building. Kelisuya, are you offering me a job? I'll take it. I will take it. All right. This is a building. Here we are. A building, a building. All right. And Teacher Coco is standing up top here. Teacher Coco likes wearing skirts, so she's going to wear a skirt today. Okay. And then we don't forget her hair. I'm going to draw my hair in red today. All right. Now, we already know how tall the building is. We know how tall the building is. We can say like, it's a 16-story building, or it's a 6-story building. So we can say the building is 14 meters tall. If the building is 14-meter tall building, and you are standing 16 meters, not 11, 16 meters. 16 meters away from the base of my building. And now we want to say hi to each other, right? And then I give you a WhatsApp and I'm like, how far away from each other are we exactly? What do you guys think we're going to use to figure out how far away we are from each other? Anybody? We could use tan. Yes, excellent. We can use tan, right? We can use tan of theta, because if this is my angle of elevation, because I've been elevated, right? I've gone up the elevator to the top of the building. I've been elevated. I have my angle over here, and this is my adjacent side. And this is my opposite side. And I can use tan. Oh no, Alicia's confused. Alicia, it's not that deep. Look, this is where I am on the ground over here. I'm on the ground over here. If this is the angle that I can measure, this side is called my adjacent side. And that side all the way over there is called my opposite side. Remember, Alicia? So, ka, toa. Which one are we going to use? So, ka, toa. We would use the toa. We would use the toa. So I want you guys to tell me, what is the angle over here? Okay, we're going to use tan to find the angle. And then you need to tell me, how far away are we from each other? Okay. Oh, actually, I'm asking I'm asking the wrong question. Remember, buildings are built straight up, straight. Buildings are built up straight. So this is going to be a 90-degree angle. How do we figure out how far away from each other we are? Anyone? Trapping more. Yes, Jonathan. Hi, thank. Guys, you need to remember the Sokatoa, because now you guys are adding in funky things and we need to make sure we remember the actual things. Because now Tangeni's written Moa, and Moa is not one of them. Okay, good. So we've got opposite and adjacent to find our angle, and we can use Pythagoras to find how far away. Okay. How far away we are from each other. Mawande, no, don't say oops, that's a good thing. Okay, that's a good thing. I know. All right, so I saw somebody, guys, give me the answer for the angle. Remember, I'm going to go tan of theta is equal to opposite over adjacent. That means that tan of theta is equal to, my opposite is 14 over 16. Theta is equal to arctan of 14 over 16. Therefore, theta is equal to what? Give me an answer. That's it, Funzo. For those of you who are saying 0.86, did you click shift? Did you forget that we're looking for an angle and we must shift angle? Did you forget to shift angle? Shift angle. That's it, Mawande. Okay, Mawande says 41,20, but Kialebocha says 41,19. And Funza also says 41,19. So who am I trusting here? 41,19 degrees. Yes, Mawande.
Ma'am, I
Yes.
kind of messed up because I didn't round off the third decimal, which is a 5. So
Okay, so it was the rounding off
51.
that wasn't 100%.
Yeah.
Okay,
So I
no,
messed
that's
up
okay.
it.
That's okay. As long as we picked it up, and it's good that we're picking it up here and not in a test, hey? It's better that we're doing it here.
Yes,
Yeah. Okay, cool, Mawande. Excellent. All right, and then I need somebody to use Pythagoras to find how far away I am from this lovely person over here with purple hair. Remember, opposite squared plus adjacent squared is equal to hypotenuse squared, and you can find me the hypotenuse side. Now remember, in this case, because we are looking for the length, I want you to take the answer you get and round off to 2 decimal places. Okay. Makolobe, it's just easier. It's easier to round off to 2 decimal places. We're not actually going all the way to the end. All right. Nice belt. Oh, I'm gonna screenshot all of these jokes. They're going on my wall. My kids at my school they already think I'm very cheesy. After this, guys, it's all your fault. It is all your fault. All right, guys. Anybody got the answer for the hypotenuse for me? Thank you, Letu. Good. I'm gonna get 14 squared plus 16 squared is equal to h squared. 14 squared. Excuse me, guys. Me dying. 196 plus, I don't know what 16 squared is. 16 squared plus 256 is equal to h squared. Add those two together. H squared is equal to 452. And then you take the square root of both sides. Therefore, h will be equal to square root of the answer is 21. Yeah, I'm like, how did we get 5? I got 21,26. And that's the distance here. 21,26. Okay. I have one last question, bonus question. Who can tell me? Oh no, I'm deleting some very important things. 14 meters. Who can tell me if my angle of elevation is 41,19 degrees, what is my angle of depression going to be equal to? Jonathan, why? You're correct, but you need to tell me why. What is the reason? That's it. Good. Mawande, what's the reason?
No, I was about to say the same thing. Ultimate angles.
Good. My angle of depression and my angle of elevation are equal as long as they're in the same plane because of alternate angles. Okay, so that's something from geometry that you learned in grade 8 that's going to come up again, actually grade 7. Okay. All right. Okay, so we're going to remember this. Now, I'm not going to give you guys a drawing. I'm going to give you guys a scenario, and I want you guys to figure out what this needs to look like. Okay. Okay, Palisa, we need to focus. All right, so it says here, Brian's kite is flying above a field at the end of a 65 meters of string. Okay, if the angle of elevation to the kite measures 70 degrees, how high is the kite above Brian's head? So what they're actually asking us, guys, is if Brian is sitting down over here I'm going to give Brian a nice pair of funky pants. That's Brian right over there. And he's flying a kite, right? And he's obviously holding a string. This is the kite over here. Nice looking kite. How long is the string over here, guys? How long is the string? That's okay, Tawang. I'll go back in just a little bit. I'm going to go back in a bit. Okay, guys, read from the scenario for me. How long is Brian's string? That's it, Unati. Good. It's 65 meters tall. Good. Now it says, if the angle of elevation to the kite measures 70 degrees, so what they're saying is, if the angle from Brian's head to that side over there, the angle that Brian's head makes with this string is 70 degrees. How high is the kite above Brian's head? So if the kite is over here, we want to know how high it is. We want to know the height over here. Now, think about this, guys. This is my angle over here, and I want to know the height. And I know some bit of information. Okay. We now need to think about what we have. What do we have, guys? And what do we want? Let me know. What do we have and what do we want? We have, I'll take a volunteer as well. Good. All right, Funzo, excellent. I've got the angle and I've got the hypotenuse. What do I want? What do I want? Compared to my angle, what is it that we want? In relation to my angle, Funzo, you're on the money, but Lechu, Mkhengi, and Tabang, you're also correct. We want the opposite. Good. So I now, between saw, car, and tower, I now need to go look for the thing that uses the opposite and the hypotenuse. Which one is that? That's it. Mkhengi's on the ball. That's it. It's the saw or the sine. So now I can go the sine of 70 degrees is equal to my opposite, which is my height, because that's what I'm looking for, divided by my hypotenuse, which is 65. And then to get rid of 65 times by 65, guys, we've done millions of these. Okay, maybe not millions, but we've done a lot. We've done a lot of them. Cancel, cancel. We times by 65. And then you guys are just going to grab your calculator, punch it into your calculator for me. 65 sine of 70, and that will give us the height above the ground. Therefore, the height is equal to, Mawande's got an answer for me. I want to see if everybody else agrees with you. That's it, Amy. Good. I agree with you guys as well. Okay, good. This is 61,08 meters. Don't forget the meters because we are calculating in meters. Okay, that's it, Snugufe. We need to remember the meters as well. Okay, Makolube, in this case, we don't have to click shift because we're not looking for the angle. They gave us the angle. The angle is 70. So we don't have to click shift. Okay. Hi, Tabang.
Hi, ma'am.
How are you doing?
Good, and you, ma'am. Oh, ma'am, for like when we have to write when like we don't have any units or measurement, is it fine if we can write units itself?
Yes, absolutely, 100%. Write units unless they just want a ratio, because some of these are ratios. And remember, ratios don't come with units, hey?
Yes, ma'am.
No, but you can, as long as you write units at the top and at the bottom, or your answer. Okay, yeah, okay. Put your answer in units. It's fine. Yes, Taban. That's good. That's acceptable.
So, ma'am,
right.
What will happen if we didn't write the measurement? Like if we didn't write meters into our answer, is the whole thing wrong?
No. How nice is your teacher? Some teachers will mark you wrong. Will mark the answer wrong, but.
My school were different because we have like at least like 4 math teachers, and And no, two of them are right. One is our head of maths. So like he's strict. Then the teacher that teaches me.
Okay, yeah, I know. Some of them are like, no, you must write the meters. And some teachers will be like, oh, okay, shame, he knew what he was doing, and they'll give you the mark anyway. So it depends on what kind of teacher you've got. I would prefer you write the meters, but if you don't, I'll still mark you right, but I'll remind you. I'll put a meters there in pen, in nice big red pen. Meters, don't
Okay,
forget.
ma'am.
Okay.
Okay, ma'am. Thank you.